Are you struggling with using background tasks in C#? Do you want to understand what is IHostedService, background service? Do you want to learn everything in practice building your real-world application using C# and worker service template? Stick around, this tutorial is for you. Let me first try to explain the concept of background task. What is a background task? Why we need to handle it. This is our application. Our application by default consists from main path. You can call it main thread. Depending from your application, you can call it UI thread. For example, for WPF, for Windows Form applications, we have UI thread. For the console application, for the ASP.NET application, we have main thread. Okay. In this case, we have only one single thread, and we are using the thread only for fast requests, only for short requests, and also only for the requests that don't require long running operation. This is our happy path. But in reality, unfortunately, it is not like that. We need to also handle the huge amount of data in our application. Like in this case, again, we have a single application that consists from a main thread. But in this case, we need to analyze large amounts of data that requires a lot of time. We need to handle large file uploads, large file downloads. We need to handle synchronization of large amounts of data. And for example, we have some sort of monitoring that requires every 3 seconds to monitor some data. So as you can see, these type of operations are really long running operations. Instead of using these long running operations in your UI thread, you need to handle them somehow to not to block your UI thread. This is the purpose of background tasks. Okay, in this case, we have again UI thread that's responsible for handling the short requests, fast requests from the user side. But we are allowing our application to have a secondary thread that's responsible for handling long-running background operations. And if you have more long-running operations, you will have additional worker threads to handle them. I think it is enough theory, and let's start our development process. First, we'll implement IBackgroundService interface using ASP.NET Core Web API. Right now, I have empty solution here. Let's right click on that, add new project, and from the project let's select ASP.NET Core Web API and hit next, and let's just call it the background service. And for the background service, I'm going to have hosted service app, the name. Okay, let's hit next. Let's use the by default template here is .NET 8. Let's hit create. I will not write the API side. We'll just focus on hosted service and Iris implementation. So the problem here is we have web API and we have long running consuming process. Every 5 seconds, we need to consume data from Apache Kafka. Of course, we'll not implement it in UI thread because we already learned that if you have long running operations, you need to implement a secondary thread and you use it to handle long-running operations. There is no need to run thread because we have hosted service and we have special injection mechanism that helps us to inject it as a background task. Okay, I'm just going to have a right click, add new folder, and let's call it services folder, and I will have consumer service here. Consumer service. My consumer service will inherit from IHostedService. This is a main interface that helps us to build background tasks. Okay, it has 2 methods: start asynchronously and stop asynchronously. Let's go for it. Let's implement them. Cool. And this is our start asynchronously and stop asynchronously operations. Let me just install our Apache Kafka to consume data. Install package Confluent Kafka. Great. And let's just configure our consumer config. Let's just instantiate new consumer config. Great. And of course, we have, as you know, we have some by default properties here. For example, we need to specify the mandatory property called bootstrap servers. Of course, we have group ID. It is also mandatory. My background group. And we have another ID called client ID for debugging purpose, for logging, for debugging purpose. You can use it. And of course, we have auto offset reset to earliest, because it is possible for us to have messages before the consumer starts. For that reason, I want to consume all the data rather than the data after my consumer started. Okay, great. And let's just go for using var consumer new consumer builder, and let's specify our key and value deserialization types here. String. If you want to learn more about message serialization, deserialization, just check my previous microservice with Apache Kafka tutorials. Let's specify our consumer builder and build. We already know that we have by default some message serialization, deserialization classes, like for string, for integer. If you are using another complex type, you need to specify deserialization using set key serializer, key deserializer, value serializer. But right now we have an Apache Kafka binary combination, and I want to consume them as a string. So I am just providing string, because behind the scenes, Apache Kafka's library will use string serializer. Great. To consume data, of course, we need to specify first subscription, and it is going to be employee topic. Why? Because right now I have employee topic in my Apache Kafka. Let's go for the topics. As you can see, we have employee topic that consists from 10 messages. Great. And of course, to start the consuming process, you need to specify consume method with time span from seconds. Let's call it every 5 seconds. To call it every 5 seconds, you need to specify, of course, while cancellation token source is cancellation requested. If not cancellation requested, it means if we haven't received the cancel, try to consume data again and again. Var, this is going to be our var consumed data. And for the consumed data, I'm going to specify if there is data, then I want to log it. For logging purpose, I'm just going to provide a logger consumer service. Let's construct it. Let's inject this logger here. Great. And let's assign it. Let's use primary constructor mechanism here. Okay. And for the logger, let's log some information, receive it, data, and let's specify our data. And it is going to be my consumer dot message consumed data dot message dot value. Great. Let's just copy and paste it here. So we have some sort of consumer data. Otherwise, we are specifying that no data to consume. That's all. And for the compatibility perspective, let's just provide return task that completed task. Okay. And if you want to use this consumer service as a background task, background service, you need to go to program CS and specify builder services at hosted service and your consumer service. Great. This is going to inject our consumer service as a singleton service, okay? And it means when I run this application, system should automatically run our consumer service also. Let's check for it. I'm just going to run my application, and you will realize that we are getting this breakpoint here. Let's wait for it. And here we are. Let's just continue. And you see, received data. Let's remove this breakpoint here. We'll just receive all the data. So you see, we are receiving. Now we don't have any data to consume. For that reason, we are receiving no data to consume. Okay, that's how everything is working. The problem here is right now I'm not able to see my web API. So where is my web API? The problem here is we have implemented our hosted service in a little bit incorrect manner. The problem here is this should be some sort of asynchronous operation, but right now we have synchronous data in it. Okay, and for that reason, this is going to be blocker for us, and it is not possible for us to run our web API. Instead of running this application like this, we need to provide some sort of additional task and run all this operation in our task. Okay, let's implement it. Private task. This is my task. Okay, and I'm going to specify task equal task factory start new. Great. And of course, let's provide our cancellation token that I'm going to use. And let's just copy this, paste it here. Now, when we run our application, we will specify task factory start new that will run our consumer in a separate thread. In this case, because we are doing some sort of long-running operation, okay, it will wrap this operation to a task, and we are just returning the completed task here. For now, it is not important. The important thing here is I need to specify also the stop implementation. But for now, let's try just run this application first to see if it is possible for us to see our UI. Let's run it. Great. Now UI is running, and as you can see, no data to consume, and the system will provide this message again and again every 5 seconds. And you see, this is our UI. Let's check. The UI is working. That's great. So as you can see, it takes a little bit time to implement this mechanism. You should specify some sort of disposable mechanism here also. Disposable to dispose your unmanaged resources if you have. You should also properly specify your stop asynchronous functionality here. This is a little bit problematic. And in most cases, there is no need even to implement IHostedService, okay? Because there are some additional management stuff that you should do when you implement your hosted service. As I mentioned, you should properly specify your task. You should properly specify your stop mechanism. You should properly specify the cancellation token. That's all on you. But if you want to easily handle these background tasks, without dealing with IHostedService, without dealing with start-stop mechanisms here, you should just simply inherit from, of course, BackgroundService. Okay, let me just comment it out like this, and let's go for another same class, public class consumer service. And let's inherit from background service. So background service is also implementing IHostedService. And this hosted service, in this case, we have template method pattern in background service. So when you inherit from background service, you are not dealing with start and stop. Instead, you have lifetime, you have a framework, a small framework inside background service, and it provides only a virtual method for you to implement. Let's go for it. So you see, you are just implementing execute. Why? Because we are using this execute in our start and stop when you inherit from background service. Let me show you. When you go to definition for the background service, you see it is specifying task like us. We have a virtual task here. And when you start your application, it is just assigning your task to execute asynchronously. It is dealing with cancellation token instead of you. So there is no need for you to think on command how I should start, how I should properly stop, how I should dispose all this stuff. So everything already implemented in your background service class. Let's implement our background service. In this case, we have single execute asynchronous method. Let's just copy our previous implementation from here. Okay, right click, copy and paste it here, and let's uncomment them. Great, cool. And in my case, I will just return the task. Why? Because there is no need to assign. The only IHostedService implementation for me required to assign it to the private task. Now I'm just returning this task. Of course, you can implement it using a variety of versions, but right now I'm just using task factory stored new. And in our case, we have stop token. Let's just rename it to cancellation token. Okay, and of course, we need to provide our logger. Logger, consumer service, and let's construct. Let's provide iLogger here. And from the logger, let's assign it to logger, L with lowercase. Okay, and let's use primary constructor. Great. Now we have all the information we need to run our application. Okay, I'm just going to use another group ID, random group ID. Let's call it like this. The problem here is the consumer group already registered in our Apache Kafka, and it has lag 0 when we run this application. But right now we are providing a new group ID. It means we should check all the data and start reading from scratch from the top to bottom. Okay, cool. Let's see what we need to add as an additional data. I think that's all. Let's just run our application. This should run our application, and plus in background, we should see our logging mechanism. So you see the logging is working. Great. Let's just continue to check. Okay. And you see no data to consume. Everything is working. UI is working. Our background task is working. So you see no data to consume. That's how we are specifying our background service. For the background service, also, if you want to specify background service as a separate solution, fortunately in .NET, we have this type of project also, and it is called worker service. Okay, let's just go for it. Right click, add new project, and from the template there is worker service. We already used this worker service when we consume data, but again, let's learn everything from scratch. For the worker service, let's select worker service app. That is going to be in our background service folder, let's say. Next, long running. create, and now everything will be really easy for you. So you see, this is our worker service, and check this out. This is inheriting from background service. You see how they are implementing these background mechanisms. Things are really easy when it comes to worker service. So in this case, this is our background service. For the background service, there is no UI thread. There is no need to unblock other thread to work properly. For that reason, we have async await mechanism here. Check this out. This is our consumer service. In our consumer service, the default template was just overridable task execute async. But in a worker, we have overridable async task here. It means go ahead, do anything you want. It doesn't matter. Everything will work properly. There is no need to specify a task here. Of course, depending from your requirements, you can specify, but for now, for the consuming mechanism, we don't even need it because it is already running in the background. So it is already running as a separate application. Great. Let me just copy all this stuff from the consumer and do the proper configuration. I'm just going to copy this and go to worker, and let's paste it here. And I just want to use this using inside my while. And let's remove this task completely. And let's specify it, and let's change it to stop a token. Great. What else we need to specify here? Of course, awaitable, simply the task, completed task. So you see, everything is really easy. No need to specify task, a separate operation, a separate CPU running, or input output bound type of things. Cool. Everything should work properly. Let's just check it. So it is going to be QWERTY group ID. Let me run it, and we should see all these messages here. Let's wait for it. And great, everything is working. You see, we're able to get data and no data to consume, no data to consume. And let's go to the messages. I just want to specify another message here to see if consuming process is succeed or not. Let's just copy this ID for worker name and for worker surname. And let's see, right now, no consuming. Let's proceed. And you see, we have for worker name, for worker surname. So you see, everything is really simple when it comes to implement background service as a separate project.